What is deep learning? Deep learning is a subfield of machine learning that focuses on using artificial neural networks to model and understand complex patterns in data. Inspired by the structure and function of the human brain, deep learning algorithms are designed to automatically learn hierarchical representations of information through layers of interconnected nodes, known as neurons. At the heart of deep learning is the artificial neural network. A simple neural network consists of an input layer, one or more hidden layers, and an output layer. Each layer is made up of nodes that perform mathematical operations on the data they receive and pass the results to the next layer. What distinguishes deep learning from traditional machine learning is the depth and complexity of these networks. Deep learning models typically have many hidden layers, which enables them to learn and extract increasingly abstract features from the data as it flows through the network. Deep learning has revolutionized many areas of artificial intelligence, including computer vision, natural language processing, speech recognition, and robotics. For example, in computer vision, deep convolutional neural networks (CNNs) have enabled machines to recognize objects, faces, and scenes with accuracy comparable to humans. In natural language processing, models like recurrent neural networks (RNNs) and transformers have made significant strides in machine translation, sentiment analysis, and text generation. One of the key strengths of deep learning is its ability to perform feature extraction automatically. In traditional machine learning, experts must manually design features that help the model understand the data. Deep learning models, on the other hand, learn these features directly from raw data during the training process. This makes deep learning particularly powerful for dealing with unstructured data, such as images, audio, and text. Training a deep learning model requires large amounts of data and computational resources. The process involves feeding data into the network, calculating the error between the model's prediction and the actual output, and then adjusting the weights of the connections in the network using an optimization algorithm like gradient descent. This process, called backpropagation, is repeated over many iterations until the model's performance improves. Despite its many advantages, deep learning has limitations. One major challenge is the need for vast amounts of labeled data, which can be expensive and time-consuming to obtain. Deep learning models can also be difficult to interpret, often described as black boxes, because it is hard to understand how they arrive at specific decisions. Furthermore, these models can be sensitive to adversarial input, small, intentional changes to input data that can cause the model to make incorrect predictions.